Greetings, this is Mark Anderson for Kellogg Community College. We are right now looking at the end of our little factoring unit here, and we're going to look at solving for x. This is going to get to the idea about why we actually factor in the first place, and I said in a previous video the reason why we factor is because when you have x and x squared in one equation, you could have up to two solutions. So another way to look at it is from a graphical perspective, is we want to know when will the parabola, when will this x squared equation, so when will the function, which is going to be our curved parabola, cross or hit the x-axis. And one of the ways that I talk about it is I'm going to talk about when will this line hit the ground, and the ground being the x-axis, because you have with the squared function, you've got one of three possibilities. You're going to have it hit the ground twice if this is an x squared function. You could have it hit the ground once in this situation, or you maybe could have it hit the ground at no time at all, like it could actually miss the x-axis. And so we use factoring to kind of figure this out. We're going to follow some rules. We're going to first of all make sure that the equation is set equal to 0, and most of the equations are set equal to 0 that way. We're going to use factoring to simplify the problem into two possibilities, up to two possibilities, and then after we do that, we're going to set those answers, or set the factored form equal to 0 to find our two solutions, or up to two solutions. Now what I want to do though is, instead of these three steps here, I want to show you using my graphing calculator. I want to show you that there is a possibility to actually kind of make some hypothesis testing based on the graph here. So if I go and look at this first equation, the 6x minus 15x, sorry, 6x squared minus 15x, and type this in, 6x squared minus 15x, I'm going to make a guess that it's going to cross the x-axis at 0 and somewhere between 2 and 3. So let me just hypothesize 2.5. Well, let's go and actually process this problem. The first step is to make sure that the equation is set equal to 0. Check. Then we're going to do some factoring. Now, a number I can factor out of 6x squared minus 15x is 3x. And that will leave inside the parentheses, if I go 6x squared divided by 3x, this gives me 2x, and 15x divided by 3x will remain negative and leave me with 5. Now, after I've done my factoring, because this is as far as I can go factoring-wise, I'm going to set each of these equal to 0. So 3x is equal to 0, and 2x minus 5 is equal to 0. I will now divide both sides by 3. So here x is equal to 0, because 0 divided by 3 is 0. And here I'm going to add 5 to both sides using a little inverse algebra step, and divide both sides by 2. So here the answer is x is equal to 2.5, or 5 halves, or 2.5. And if you look at the graphing calculator screens, you will see that the two intersections where this parabola crosses the x-axis is at the origin 0, 0, and also at 2.5, 0. So 0, 0 and 2.5, 0 at these two locations. Let's continue on, and let's go to problem number 46. If I go and type this equation in, I can make some hypotheses based on where this is. So x squared minus 12x plus 20. Let's look at our graph and see where it crosses the x-axis. Okay, it looks like it crosses the x-axis at 2 and at positive 10. So let's actually do the math and see if that works out algebraically. So, since this is an easy trinomial problem and it's already set equal to 0, I'm going to find two numbers that multiply to make 20 and add to make negative 12. The two factors that multiply to make 20 and add to make negative 12 are negative 2 and negative 10. If I set these equal to 0, so that one possibility is when x minus 2 is equal to 0, and the other possibility is when x minus 10 is equal to 0, I can then add 2 to both sides, and x is equal to 2. There's one possible answer. If I add 10 to both sides here, then I get x is equal to 10. So it looks like my answers are 2 and 10. Those are my two possible answers, problem number 46. Problem number 47, much like problem number 46, starts off with an easy trinomial with a couple quick modifications here by changing this to a plus. Now it is plus 2x, and I'm going to subtract the 35, and hit graph and check to see what are my two possible answers. So it looks like my answers are, if I had to guess, at a -7, and it looks like a 5. Now, you should be able to start seeing now the relationship between the graph and the possibilities of factoring. This equation is set equal to 0, so what I will do is I will now find two numbers that multiply to make -35 and add to make +2. This is going to be a +7 and it's going to be a -5. These two multiply to make -35 and add to make 2. If I set these equal to 0 as my two possibilities for the problem, I am then going to subtract 7 from both sides. X is equal to -7, so right there. And here add 5 to both sides, so x is equal to +5. Right there. Okay, so those are my two possible answers, -7 and +5. Okay, so on to the next problem, which is a binomial. I'm going to type this in as, let me clear this out this time. So 9x squared, whoops, not 9 squared, 9x squared minus 144. Alright, looks like this hits the ground at -4 and +4. Now, one way I can make this problem easier is I can factor out a common term. And 144 and 9, you can actually divide 144 by 9. So if I factor out a 9, this gives me x squared minus 16 is equal to 0. So here I have 9 and I have x squared minus 16, which can be broken into x plus 4 and x minus 4. Now I'm going to set these equal to 0 and solve for x. I subtract 4 from each side. X is equal to -4, which is one of my answers right there. And add 4 to both sides, so x is equal to +4, which is right there. Now you're wondering about the 9. Should I set the 9 equal to 0? Well, if you do, that's an incorrect statement. 9 is not equal to 0. Besides, 9 is a coefficient which just changes the speed of the problem, or in this case the height, since it multiplies the original a or amplitude by 9. None of that's really important to finding where the roots are, which in this case is -4 and +4. So moving on to the next problem, we're going to have to do a little bit of work before we get this started, because at the start of this problem the 40 is on the wrong side. So I would have to move the 40 over by subtracting it. So here I'm going to have x squared minus 3x minus 40, because I have to have the I have to have the equation equal to 0, and now I can look at my graph and hypothesize where that's going to cross the line. So it looks like it crosses the line at -5 and +8. So now let's look at the algebra and see if that matches, which it will. I am going to have the subtraction of 40 from both sides. That simplifies to 0. So x squared minus 3x minus 40 is equal to 0. I am now going to factor this out. Two numbers that multiply to make -40 and add to make -3. I have x, which is -8, and x plus 5. So some of you have seen now that there is a nice little pattern here. Whenever you have a 1 in front of these x's, it looks like it will basically cross the x-axis or hit the ground at the opposite version of this. And this is holding true because you're just moving it to the other side, which is changing it from a positive to a -5 and from a -8 to a +8. So our next problem is going to be a little bit tough because it is going to be a problem where I do have to move the 4 over, but it's also going to be a tricky trinomial. So if I go to my y equals and I type in my 3x squared minus 8x plus 4, here's what the calculator is going to let me down a little bit, because it will show me that this intersects in two spots, but what's unfortunate about this is that those two spots are not very recognizable, at least from what I'm looking at here. So what that means is that means I'm going to have to kind of do this brute force and figure this out using tricky trinomials here and get the answer, and then look to see if it's between 0 and 1. And it looks like, from my perspective, it's somewhere between 1 and 2, but maybe it lands right on there. I don't know. I should just do my factoring work, and this is going to be tricky trinomial work here. So I'm going to add 4 to both sides, so 3x squared minus 8x plus 4 is equal to 0. So I'm going to multiply 3 times 4, which makes 12. And these rules were covered in an earlier video that talks about factoring trinomials where the leading coefficient is not 1. So I multiply my 3 times 4 to get 12. And now I need two numbers to multiply to make 12 and add to make negative 8. Well, that's pretty easy because negative 2 times negative 6 makes positive 12 and adds to make negative 8. I call this the Atari step, so I split that up by writing my negative 8x as negative 2x minus 6x. So my 3x squared is there, plus 4 equals 0. And now I'm going to group this. I'm going to then factor out here an x, so I've got 3x minus 2. Here I'm going to factor out a negative 2, which is going to give me 3x minus 2. Now, from my pattern of grouping, I would write my x minus 2 once, and I would write here my 3x minus 2 once, and there's my complete factorization of 3x squared minus 8x plus 4. Now if I set this equal to 0, it looks like my hypothesis was right, that x is going to be 2 right there. But this one's going to be a little bit harder to see and figure out, so I'm going to set my 3x minus 2 equal to 0. If I add 2 to both sides, I get an answer of 3x is equal to 2. Divide by 3, x is equal to 2/3. So that hits the ground at roughly 0.6 repeating, or 2/3 of the distance between 0 and 1. So no matter how good the calculator can give us a chance to give us approximate answers, when we start to get into this mode, we're going to have to just do our work and then find where it hits the ground using the algebra. Alright, so having said that, I'm going to put the graphing calculator away. There we go. And I'm going to now do the rest of these problems by hand. So in this case, this problem is not set equal to 0. In fact, I need to move the 14 over, but I can't really do that until I FOIL out this problem. So I'm going to do some first outside, inside last. Whoops, my pen's slightly not working here. So first outside, inside last. So it gives me x squared, and then it gives me 2x, that's my outside cables, inside cables, and then my last cables. But then I'm going to subtract the 14 from both sides to get the problem equal to 0. So here's my negative 14. Now my problem is equal to 0 because the minus 14 and the positive 14 made 0. So now I'm going to simplify these 5 terms. The x squared stays the same. The 2x minus 3x is negative 1x. And the negative 6 and the negative 14 make negative 20. Now I can factor this and get my two possible answers to the problem. So x minus 5 and x plus 4 is equal to 0. So if I set those equal to 0, because those are two possibilities for my problem here, I get the answers of x is equal to positive 5 and x is equal to negative 4 if I move the 4 over by subtracting. So again, in problem number 51, you would FOIL this out because the 14 has to be moved over, and then you simplify, and then factor that again. Now for problem 52, you'll see that it's already equal to 0. And it's already factored, because if you actually FOIL this out, you just have to factor this out again. So your answers are 3 and negative 2. Okay, so for our final two problems here, what we're going to do is we are going to first distribute this x to the x plus 10, and that gives me x squared plus 10x, and then move the 11 to the other side using subtraction, and now I have the problem set up for easy factoring. Because you're supposed to get the trinomial set equal to 0, and then factor, which in this case, two numbers to make negative 11 and add to make a positive 10 is going to be a positive 11 and a negative 1. Set this equal to 0, x plus 11 is equal to 0, which means x is equal to negative 11 if I move that over. And here, if I take that x minus 1 equal to 0, I'm going to move that 1 over to the other side, x is equal to 1. So, those are my two answers to that problem. So our final problem today, problem number 54, we are going to FOIL this out, move the 25 over, and then we're going to check to see what we need to do to get our final two answers by factoring what's left over. So let's do our FOIL. 2x times x is 2x squared. 2x times negative 1 is 2x. 3 times x is 3x. And 3 times negative 1 is negative 3. If I move the 25 to the other side using subtraction and set that equal to 0, I can now simplify these 5 terms into 3 terms, 2x squared plus x minus 28 equals 0. And now what I have is a tricky trinomial. A tricky trinomial that's solvable. I can find my answers to this problem pretty quickly by just using that 4-step technique that we learned in a video called factoring a trinomial where the leading coefficient is not 1. I'm going to multiply the 2 times the negative 28. If I multiply the 2 times the negative 28, I get negative 56. So I need 2 numbers to multiply to make negative 56 and add to make 1. Now, I know that 7 times 8 makes 56, but one of these numbers has to be negative. Since I need a positive 1, that is going to be the negative 7. So I'm going to split this up into, and I'm going to kind of continue writing up here, since I got a little bit more room, 2x squared minus 7x, and then I'm going to have a 8x minus 28 equals 0. That's splitting the 1x into negative 7x and 8x to give me that 1x. So here I'm going to factor out an x, which gives me 2x minus 7. Plus, here I'm going to factor out a 4. If I factor out a 4, I then get 2x minus 7. Now that I have my match, I can write that once, and the leftover gets put into its own binomial, and set that equal to 0. So now I have my 2 binomials to set equal to 0, so 2x minus 7 equals 0, and x plus 4 equals 0. Move the 7, so 2x is equal to 7. Divide by 2, x is equal to 7 halves, or 3.5. Here I just move the 4 to the other side, so x is equal to negative 4. So my answers for this problem are 3.5 and negative 4. Well, thank you very much for watching my little equation solving problems using factoring and the graphing calculator. Again, thanks for sticking with the factoring section.